Does it work now? Is it on? Cool. So good that I have people also in the stream. So let's start from the beginning. Hello, everyone. Good morning. Hey, I lost basically everything because I basically said everything. Let's start from, what am I hearing? Okay, perfect. So last technical hiccup, I hope. Again, good morning, everyone. Welcome to our third day of the Zero to Blockchain Bootcamp. We already showed you what you can do with TypeScript, let's say a Sol transfer or Blinks, which is more or less the front-end facing part, or the TypeScript part. We already showed you what you can do with Anchor. Shout out to Dialect. Thanks so much for supporting us on day one. Shout out to Turbine, to Andre, to Jeff, to supporting us on day two and show you what you can do with the Anchor framework. And today, I'm super excited to show you a bit more what you can do with NFTs. To do so, we have Leo and Shaku here. They're gonna teach you everything you need to know. NFTs are super powerful instruments. I think this is what you should know already, and how you can really get the best out of it. All the AMA and questions you might have, we will answer them today. We have a few code examples there, and it's gonna be really fun, I hope. For me, I'm really looking forward to this, and I think, yeah, you will get a lot out of it. 2-3 more slides. I wrote a few times, we're gonna have fun today. Why is that, you might ask? So first of all, there's gonna be an event after this event in the evening at Prachtwerk. So, you know, we are talking today about NFTs, about artists, about art, and we are in Berlin. And Berlin, this is a huge part of the culture, right? And what we have today, this is something a community member from us is doing. It's called Open Stage, which is basically an open mic where people can come and they get 6 minutes to present a poem, song, write a song, tell about everything you might think about NFTs. Last time we had Esther from Drip there. We already had cooperations with Soulflare and Drip, as I said before. So it's a really nice event. It's for free. So if you don't know what to do this evening, I will be there. I hope you're gonna be there as well. It's gonna, yeah, it has free drinks as well. Thanks, Rob. And it has an amazing photographer as well. So, yeah. You can ask Bloody about this. I have no idea. But anyhow, if you are in Berlin and you don't know what to do this evening, meet us there. It's gonna be really fun. And it's, as you heard before, it's a free event. There's going to be drinks, there's going to be artists, art, and fun. And merch. There you go. There's going to be merch as well. Cool. Metaplex said that, by the way, for the record. And then the second thing I want to tell you, because even more fun, is when you make money, right? So we have bounties prepared for today. Because we thought now at the end of the workshop, it might be fun for you to write about it or to get in touch with the tech. And we thought about what we could give you as bounties. And the way it's going to work is we have a platform. It's called Super Team Earn. If you heard it before, at Super Team, you think you should not buy your first crypto. Instead, okay. Sorry, Mom. I'm online. Okay, so not the last technical hiccup. I knew when I said it will happen. Okay, anyhow. So yeah, so for our part about Super Team Earn, as I said before, it's a platform where you can really earn crypto by doing cool stuff. It's gonna be maybe challenges for bounties, but there's also grants that you can have. So if you have a nice open source idea and you really want to get this thing in live, you don't have to do this for free. You can get a grant for it. I did a developers guild last week about it. So if you want to hear more about this, feel free to look in our YouTube channel, look it up there. And to our bounties, so it's 2 easy bounties. The first bounty is share your insights. This is literally just a thread on X. The way it works, you will see all the requirements on the website itself. The website is earn.superteam.fun, and it's gonna be released during the day. So I will give you a heads up once the challenge is there with all the requirements and everything. But to give you a short information, it's basically just a Twitter thread, right? You write down what you learned, and that's basically it. And then you submit it on Super Team Earn, and you can make money or win money. The second one is build a small project. Leo and I was sitting a long time there thinking what we could do to make it a bit fun. The idea is basically that everything that you learned here could be something with links, could be minting an NFT, could be writing a program, doesn't really matter. The question is, how can you adapt what you just learned, right? And the idea behind this is that we give you this bounty, and the bounty, I already told you what it is. You can just start thinking, okay, what could I do? It doesn't have to be like a huge, big project. It's just like that you apply what you learned, and then you push it into a GitHub repository, and by Friday it ends. And you are not alone with this. Today you can already start with this bounty. Then tomorrow is gonna be a day of hacking. So be logged in and do whatever you want, play around with the code and stuff. And then on Friday, we have co-working Fridays, same area here, same spot. And then Leo will also be there, and he and I will be there to help you to finish this thing if you run into any problems. And then by the end of the day, I think in the afternoon, the challenge will be over. So you have to submit by then. Right? Thumbs up. Nice. Good. Okay, that's been it from my side. I would like to open the stage to the Metaplex guys. I'm super grateful that you are here. Charco is the first time in Berlin, so I'm super excited to show him the city later. And yeah, guys, please come on stage. Woo! All right, I give you the mic.
Hey everyone, I'm just gonna say hi real quickly and introduce Leo here. Everyone knows him, but my name is Charco. Some of you I met before, some of you I didn't. So I am not from Germany, but everyone who met me knows that I speak German very fluently, and I visited most of Germany, but I've never been to Berlin. So I'm really looking forward to see the city today. But other than that, listen closely to Leo. He is the guy who's going to teach you everything about Metaplex. One thing I'm just going to mention is the fact that we don't only do NFTs, we do everything. And probably most of you don't know this, but like 90% of fungibles that were created in the past 6 months were also been created through Metaplex one way or another. So even if you're building a project that doesn't really use NFTs, you can also use Metaplex, and you can always reach us through Leo, through me, through anyone else. After this is all over, I have some merch for all of you. So just come by, let's talk, let's connect. And now I'm giving the stage to the main guy here. Give it up for Leo.
Thank you, guys. I'm gonna just talk loud. Sorry, guys, I hate microphones, so I'm just gonna talk loud. Hopefully everybody can hear me. Can you guys hear me at the end? Let's go. So before we start, I'm just gonna say a couple of words. Today, pretty much, you will learn everything that is here to learn about Metaplex, all the standard, how to use them, how to start your first NFT candy machine too. One thing that I ask you is, if you guys have any ideas, want to give back any feedback, you find any problem, please come find me. We want to hear your thoughts, and we want to actually improve the protocol on the level by the people that use that, so you guys. So please send me a DM if you're online. Come find me here if you have more ideas for new core plugin, new functionalities, new feature that we should add to our protocols. So yeah, I guess let's start. Metaplex, powering the digital asset economy on Solana and the SVM. Why the SVM? We just deployed both on Sonic and Eclipse. So you can find all the things that we're talking about today on other network extension as well. So what I'm going to say right now, it's valid for every network extension that we're deployed on. So if you ever interacted with a fungible or non-fungible token, it was probably done via Metaplex. As Charco said before, 99% of the non-fungible asset runs through Metaplex, and most of the fungible token, as well as the Metaplex metadata on top. Pretty much the way that it works is, if you see the image on the Solana Explorer, Solana FM, or pretty much in your wallet, most probably that was done by adding the metadata to the token through Metaplex. So what is Metaplex? Metaplex is not just a protocol. Metaplex is 3 different things. So we have the foundation. The foundation is a non-profit organization that supports the development, security, and the centralization of the Metaplex protocol. Pretty much, if you see grants, if you see hackathon, if you see everything that actually can help the ecosystem grow, is run through Metaplex and through the DAO. The DAO is a decentralized network of MPLX token holders who govern the Metaplex protocol. So most of the decision on the protocol level, so for example, if we want to, now token metadata is immutable, but before, if you wanted to add or propose like a feature for token metadata, you could go through the DAO, get a vote, and then we would add it if like the vote passed. And the same thing happened, for example, with grants and other stuff. Everything goes through the DAO. The MPLX holder can vote to pretty much like improve the old protocol. And then, as I said before, we have the programs. It's a suite of token standard programs and resources that enable developers to deploy and manage digital assets on Solana and the SVM. So pretty much we do developer tooling, we do fungible standard, we do non-fungible standard, and we have, in my opinion, a pretty good developer app. So if you're interested about learning more about Metaplex, just go to the developer app. We will have a link at the end of the presentation. Our impact. So since since we created the first metadata, we actually created 563 million digital assets. We have 627 million transactions to date, probably actually even more. I think now we reached 700, but when I written the presentation was just 627, and we created $1.2 billion in creator revenue. Thank you. Pretty much everything. So like for creator that created NFTs, but even like for protocol that uses NFT in different way. And this was done across a lot of vertical. Some of the one that we're very, very excited about is, for example, real world assets. We will see the example of Baxus later. We have meme coins. Pump.fun actually uses our metadata to deploy the token. Gaming, deepin, art, pretty much everything that can be used as a digital asset, we want to support it. Some of the names that you might know in the Solana ecosystem that uses Metaplex are Magic Eden, Tensor, PhotoFinish, Ilium, Star Atlas, and Pump.fun. But we'll see some of the use cases and some of the standard later. So here we have Andre, that is our new community developer. There is me, there is Sharko, and so pretty much if you need anything else, these are our Twitter. There is, if you can send an email to partnership@metaplex.foundation in case you want something a little bit more institutional, we can say. But Twitter is completely fine. We're DJ like you. So what can you do with Metaplex? First of all, does anybody know what Metaplex does? I talked about digital assets, but something more specific.
Know that there is the JSON file, and inside there you pull kind of the data onto the NFT, right? Something like that.
Yes, exactly. Yes, the standard support the possibility of like uploading the data into a JSON file that gets uploaded to a decentralized storage system, and that can be fetched every time somebody goes, for example, to the Explorer, or using DAS, that is our own indexer for digital assets. So first of all, we're going to talk about token metadata. Token metadata has two different use cases. The first is that it attaches additional data to fungible or non-fungible token. So this means that token metadata works both for fungible and non-fungible. Naturally, they are different between the two things, because non-fungible token, we know that they need something very, very specific. For example, they need the supply to always be 1. the decimal needs to be 0 because it cannot be divisible. So the way that this stuff is done is by adding the metadata that has all the information about the NFT itself. So for example, the image, the royalties, and everything else. And then in the case of non-fungible token, we have a master edition that is an account that is created to enforce the fact that the mint has 0 decimal and there is only one supply that cannot be minted more. So these are the main difference between non-fungible token and fungible token on token metadata. If you can see, if you are into NFTs, you might recognize Claynosaurus, DJ Ape Academy, or if you're into meme coin, you will recognize the logo of Pump.fun. These are only some of the partners that we work with on token metadata. Then we have Bubblegum. Bubblegum is really, really interesting because, first of all, it powers compressed NFTs. That is something that is natively done on Solana. And pretty much compressed NFT make it possible to scale the creation of NFTs to a new order of magnitude by rethinking the way we store data on chain. So the way that it works is the data about the NFT, the data about the image, and everything pretty much that is about the NFT gets stored into a Merkle tree. So it can be verified on chain, but all the data is actually stored into a database. That makes it super, super cheap to actually mint 1 million NFT, for example. Because now the fee is only the storing the data of the root of the Merkle tree on chain, and the rest of the verification are done off chain and verified on chain. Some of the use cases that we saw is a lot of gaming. We have both Photo Finish and Star Atlas that uses compressed NFTs to mint millions of NFTs every day. Then we have Drip. Today was in the advent calendar, there was for the super team Germany member actually got like tons of droplet. And Drip pretty much makes it super, super easy for artists to distribute their art to million people. And they use compressed NFT as well. And then we have Ilium Mobile. Their hotspot is actually represented by a compressed NFT in their wallet. Hybrid. Hybrid is our latest program, and it makes it super, super easy to exchange non-fungible token into fungible token. So there are some projects that are exploring the fact that they want to launch an NFT collection because they really like the art, but at the same time, they want all the liquidity benefit of a fungible token. So for example, having the possibility of integrating with the AMM, having the possibility of integrating with Jupiter, and in general, like having the possibility of, for example, increasing the holders count on chain. How do we do that? We can do that with Hybrid. Hybrid is not other than an escrow that contains both NFT and fungible token. It makes it very, very easy through just a simple instruction to swap between them. Two of the mechanics that are, in my opinion, are very, very cool is, first of all, the swapping that we just talked about, but the second one is the re-rolling. So the way that the hybrid works is that every item inside of that has a rarity, and you can continue to re-roll for a very, very small fee in trying to get the NFT that you actually want, and not the one that you're stuck on. So for example, I have an NFT that I don't like. I could just pay a small fee till I get the one that I like. So it makes it even easier for a creator to, for example, explore some gamification in that, because they could, for example, introduce a limited trade for like a week, and they can generate tons of revenue through the fee feature. So it's a new way for creators to monetize their work as well.
A question?
Yes.
Where does the liquidity come from when I swap the tokens to the NFT or vice versa?
So everybody can create an escrow. They will need to put up inside some tokens that they can be swapped for the NFTs. But for example, you could create like a one-side liquidity at the start and say, you can only swap into NFTs. Like there is only circulating token. You can swap it into NFTs. And so it's like you deposit the token and you get back the NFT. Now, every time you want to burn the NFT, you take back the liquidity that you put into the escrow. So every time we swap, all the tokens and all the NFT always stay in the escrow. And the only thing that goes to the creator is the fee. And so there is always liquidity to do both.
Interesting concept, yeah.
And Core. I'm very, very excited about Core. It's my favorite program and is our new digital asset standard for non-fungible token. So we talked about before how token metadata actually work with NFTs, and is that we have the mint account, the token account, we have the metadata account, and we have the master edition. The beauty of Core is that Core has a single account that store all the data that we need for non-fungible assets. So before talking about a little bit more about like how Core works, I think it might be interesting to see why we actually decided to create a new standard. 3 years ago, that was the first NFT that has ever been minted. It's like this we can say this dragon that is called Creature. And 3 years ago, that was the first NFT. Now I think it's 4 years ago, actually. But yeah, pretty much everything happened with zero optimization. Like not the same program, but most of the part of the program that we had available 3 years ago on Solana is still used to this day into token metadata. And so, first of all, it's built on top of the SPL token program that is very, very easy to integrate with existing flow, but at the same time is not really optimized for non-fungible token because it was built for fungible token. As I said before, it requires multiple account and is bulky and expensive to work with. That's why we actually decided to introduce Core. As I said before, there is a single account structure, and the way that we thought about it is what do we need from all the account and all the field that we already here that we can put into a single account. And if you go through the different the single accounts, there is actually a lot we can do. For example, the mint account, we actually don't need anything that is in there. We don't need the supply. The supply should always be 1. We don't need the decimal. This decimal should always be 0. We don't need the freeze authority natively. We can add that to our plugin, and that's what we do in Core. And the same thing, we don't need a mint authority because we cannot mint more than 1. Same stuff with the token. We don't need the amount. We don't need the delegate. We don't need anything. We just need to know who owns the account. So we completely deleted two accounts that were in token metadata by just replacing it with one single field that is the owner field. Same happened with the metadata. The metadata has the name and the URI, and we put it into the asset v1 account. And the master edition now it's not needed because you don't need to enforce anything because you can't actually mint more. It's done at the protocol level. And this left us with a single account that is 10% of the size of all the accounts that were needed before. So pretty quite a very big improvement, in my opinion. But it's not just an improvement on the space. It's an improvement of the old DevX. For example, if we wanted to do a transfer on an NFT before, we always needed 3 different accounts. We needed the mint, we needed both of the token account, and actually we needed the master edition of the mint, the metadata of the mint, and even in the case of PNFT, an additional account that actually enforced the freeze and the locks of the NFT. With Core, it's super easy. You just change the owner field. How can it be easier than that? So if we go back on what we see in the asset v1 account, we actually see that there is no collection in there. What? Did we just get rid of collection? No. Actually, we made a very clever, we set it up in a very clever way. That is, if we think about it, we don't need update authority for every different asset if they're grouped in a collection. We probably just want the collection authority to be able to upgrade all the assets in a single way. And that's exactly what happened. So in the update authority field on the asset v1, you can set it to none if you want to set it, for example, to be immutable. You can set it to an address if, for example, it's not part of the collection, and the address will have the possibility of like update the asset itself, or you can set it to a collection. What we'll do is inside the pub key inside of the collection flag will have different field and update authority itself. And so this means that every time we want to update the asset, we will just need to pass in the collection, and the update authority will be validated against the collection instead of against the asset. Inside, we can see that it's not the same as the asset we want. For token metadata, collection were actually token metadata NFT that didn't have collection. They didn't have a collection set. For the collection we want account is different. We just have the name, the URI, and two other fields that are pretty interesting. There is the number of asset minted and the current size. So for example, if you wanted to create like a collection that burn itself through time, for example, SoulSlug is one of the biggest, I think, deflationary collection on Solana. You could always know that, for example, you minted 10,000 NFTs, and you could always see how much NFTs actually are current into the collection after all the burn and after everything that happened, pretty much. So what about functionalities? We created a new standard. Do you think we would left without adding anything on functionalities? That's why we created plugins. Plugins is our new innovation that is pretty much, it makes you the possibility of creating an on-chain app for your NFTs natively in the standard itself. What does it mean? For example, for staking, there is the permanent delegate. There is the possibility of using attributes on chain. There is the possibility of adding all these different functionalities natively with a simple instruction. So you don't need to chew glass. You don't need to create a smart contract. You could do that all into TypeScript by just using all the instruction that we created for plugin and all these new functionalities that we created with plugins. We're going to see some example later when we go into the code. But at the moment, we can say that there are three different types of plugin. The different types depends on who can actually add it and modify the plugin itself. So we know that there are some, as we said, some native functionalities, but we should, for example, the update authority shouldn't have the possibility of adding, for example, of freezing the asset if the owner doesn't want to. And so that's why the freeze delegate is actually an owner-managed plugin. What does it mean? That if that plugin can be added to the asset only if the signer is the owner. One of the key that signed the transaction is the owner. Then you have the authority managed. For example, you don't want to give the possibility to the owner to change the attributes of the plugin. And that's why the on-chain attributes are an authority-managed plugin. So what does that mean is that only the authority can change the data inside of it. And then we have the permanent plugin. So the way the permanent plugin works is those can only be added when the asset is minted. And pretty much, there are three different permanent plugins. That is the permanent freeze delegate, the permanent burn delegate, and the permanent transfer delegate. And what does this mean is that the authority of this permanent plugin can always, for example, burn your asset, freeze your asset, or transfer your asset. And this is really interesting for some of the use cases, for example, soul-bounded NFTs. Today, we're going to use the permanent plugin to create a soul-bounded NFT. But that's not all. We wanted to push a step forward on functionalities, and that's why we created external plugin. The main difference between the normal plugin and external plugin is that external plugin has two different parts of it. The first one is the adapter that sits on the asset and pretty much points to where the data is stored, but the data is actually, the data and the validation is actually stored in a different part of the asset or outside the asset altogether. One of these examples of this external plugin is, for example, the app data, something that I'm very, very excited about. If you scan the QR code, you'll see that there is a fully write up and a fully fledged example on how to create, for example, a ticket program. So you could use app data to create something like Ticketmaster. And it will be super, super safe because the way that app data works is that you can give the authority to somebody else to write into a specific part of the asset. So this means that the asset will not be changed by the authority over the app data, but only this small part will be changed by the app data authority. This makes it really, really interesting in some use cases. For example, in the case of a venue. So you could create, Ticketmaster will issue the ticket, or the decentralized Ticketmaster will issue the ticket, and all the tickets are safe because nobody can change it if not the decentralized version of Ticketmaster. But what about how can the venue authority, for example, enforce the fact that that ticket has been scanned? You could put it into app data. You can say, oh yeah, let's scan the app data and see what the app data says. You give the update authority over the app data part to the venue authority, and the venue authority can write, yeah, this ticket has been claimed, this ticket has not been claimed yet. Oh yeah, actually, this is a flow that pretty much explains what I just said. So Ticketmaster creates an event, for example, in a collection. So all the events data are saved into an attributes plugin that is on the collection itself. So you can save so much space because you pretty much everything that is the same for every ticket can be just saved on the collection one time and be reported on every ticket that way. And then you can issue ticket that are, for example, have the what's the position, what's the entrance, and let's say all the data that it's individual on each ticket. This ticket then can be scanned, and the update authority, that will be the venue authority, will say, for example, will write claimed. So what that means is that the next time somebody uses the same ticket, the app data plugin will say already claimed, and will not let you go in, because by saying already claimed. And this makes it super, super safe for both Ticketmaster and the venue authority to do so, because Ticketmaster knows that the ticket will not be tampered with, and the same, the venue authority doesn't rely on Ticketmaster to actually claim and like say, yeah, this has been scanned already. Yes.
The app data.
Yes.
This is one specific app, or this is like a general way to handle it?
This is a very specific plugin, exactly. So you can access these like all this stuff by just calling an instruction that is add app data plugin to your asset. I skipped over here before, but I said this at the start of the workshop. Please, if you have any plugin ideas, if you need a specific use case for your program, reach out to me or the guys that are here, because we actually want to hear from you and we actually want to develop the feature for you. So yeah, if you want to learn more about core, you can just scan this QR code. It will take you to the developer app and pretty much everything that you need to know about all the plugins, how to start. We have guides. Everything pretty much you need to know about core can be found inside of this QR code. So I'm gonna explain some code example. Then we're gonna take a small pause so we can recharge. But pretty much what I want to show you guys today is how easy to create a soul-bounded asset with specific attributes on site. For example, to create a proof of participating to this workshop, for example. So we're gonna use just two plugins. The first plugin is going to be the permanent freeze. As I said before, the permanent freeze is added when we mint the asset, and it gives the possibility to the freeze authority to always be able to freeze the asset inside of your, always the possibility to freeze the asset. So by, for example, setting the frozen Boolean to false and giving the update authority to none, we could create a soul-bounded asset that can never be unfrozen. And so pretty much a fully soul-bounded asset natively. Then we're going to use the attribute plugin. As I said before, we have the possibility with core, we have the possibility of adding attributes in a fully on-chain way. So pretty much instead of like saving it into the metadata in the URI, we finally can access all these attributes on chain. So in a smart contract, we can finally safely access all these attributes that we added to the asset. There are two values, the key and the value. The key is pretty much the title of the attribute, and the value is the value. So for example, for proof of work NFTs will probably be the key will be date, and the value will be the date of today, for example. Some of the use cases that we can actually use attribute plugins, for example, gaming. We have an example of using a gaming application by using, for example, a backpack. You could create a backpack with on-chain attributes. And in each attributes, you actually save, for example, the item and the quantity that you're actually storing into that backpack. Can be used for on-chain trades if you have a collection, and it can be used for a points and referral system. We saw some our partner, for example, Arcium, it didn't integrate it yet, the points and referral system, but they use core and soul-bounded asset to pretty much create a proof of work that said, yeah, you went through our course about what is Arcium. So yeah, let's take a pause of 10 minutes, and then let's come back to show how to do that inside of the code. Thank you, guys. Oh, I need to. Yeah. Good. Yeah? That's cool. That's cool. Yeah, for sure. Love to.
Can you give it a few more buttons?
Yes.
That's on the screen.
Yes. So, okay, I am open. Okay.
Yeah, it's good, right?
Good?
Yeah, what would you say? I think it'll be
Yeah, I
great,
think, yeah.
big enough.
Yeah, I think more bigger than that. Probably, yeah.
Yeah, and maybe I can even switch this. Did I get it right? The owner of the creator of the NFT can earn the NFT collection if it's out.
Not always, just if they have the permanent burn plugin.
Alright. But you invented it now. So now it's possible.
Yes.
Now it's possible. Before that, it wasn't possible.
No.
If you threw a collection out,
It-
it would stay the whole time.
Yes.
Now it's possible.
Yes. Cool. Should we? Let's restart. So, as I said before, we're gonna first of all we're gonna try and learn how to use Metaplex Core a little bit more using just our TypeScript SDK. So we're gonna start by minting a collection and an asset, and adding the soul-bounded plugin and the attributes plugin to that as well. After that, we're gonna update the plugin to be able to unfreeze the asset and burn the asset. So let's start with, I have some code is already written. This will be a template that you can find on the GitHub that we're gonna upload at the end of the day. Pretty much the way that I set it up is that you have both templates and example. The example is the full thing done, and the templates is something that is starting that tells you, okay, you need to fill up the gap, but it's easier than starting from scratch. If you really want to start to learn about how to use Metaplex and how to use Metaplex Core, please, at the end of the workshop, go back to the templates and try doing it yourself. This is the best way, in my opinion, to actually learn how to do that. Cool. So there is some boilerplate that is already written. We're gonna go a little bit more in depth in the next workshop on how Yumi works. But for the moment, just know that Yumi is our TypeScript client, our JavaScript client that pretty much works the same as Web3.js. So we, yes. So I don't have it uploaded right now. I'm gonna upload it at the end of this workshop with everything for the whole day.
All right.
Sorry about that. I forgot to upload it. So, first of all, we're gonna connect to the to DevNet, LocalNet, or Mainnet, whatever cluster we want to operate on. Then we're gonna open the wallet.json file that we're gonna create later, and then to function, we need to set up Yumi with a signer identity. The way signer identity works is we have both signer identity, payer identity. Signer identity is pretty much who is going to sign for the transaction. So for example, who's going to be the owner of the asset, everything else. Payer identity is who's going to pay for transaction fees. Two different identities. We'll talk a little bit more in depth about how that works in Yumi after this workshop. But yeah, so let's just start by generating our first collection. So first of all, to create a collection, we need to create a new key pair and a new public key where the collection will be stored. To do so, we just use generate signer, we pass in Yumi. Yumi will need to be passed in pretty much in every instruction that we're going to use today. So then we console log the collection address, so we can see that on the Explorer, for example. And then we start by creating the create collection transaction. The way that this works is we're going to use the create collection instruction, and all the instruction from Metaplex follow the same rule. So the first thing is always going to be the UMI that we want to use. And then we're going to open the parentheses, and we're going to pass in all the fields that create collection asks us for. So if we are not sure what accept, we can or go to the developer app and see what are all the different fields, or we can just command click or control click on the function itself, and we can actually see what are the args. So in this occasion, the args will be the account will be collection, update authority, payer, and the system program. You can see that the update authority, the payer, and the system program are actually optional. This is because thanks to the way that we set up the UMI, we can actually, the update authority will be the same as the signer identity if we don't pass in anything, and the payer will be the same as the payer identity if we don't pass any field inside of that. The system program, it's not needed to because the UMI will fetch it for us. So it's pretty much never needed to be passed in. Then we will need to set in the name, the URI, the plugins, and the external plugin. Naturally, plugins and external plugin are not needed because we could create an asset that is just an asset itself. But in this occasion, we're going to set the permanent freeze plugin on the collection, and we're going to set the attributes on the singular assets. So I'll say, let's start. So as we said, we're going to pass in the collection. We're not going to pass in update authority and payer authority because we don't care. It's just an example. So we're going to just use the UMI identity. Then we need to pass in the name. So collection, for example. Oh, I need to, yes. And then we need to pass in the URI. I didn't prepare anything for here, but pretty much the way that it works is you could use the Iris uploader. There is a guide on our developer app to upload the metadata, and this will give you back a URI link, and you can just pass that in inside of the URI field. Other than that, as I said, we want to add a plugin. So it's going to be an array because we can add more than one plugin at creation. In this occasion, we're just going to create one. So we want as type, we want the permanent freeze delegate. We can see that I explained it before that the field that in the permanent freeze delegate will be the frozen. But in case if we don't know, we can just right click and we see type permanent freeze delegate args, and the only args that requires is the frozen args. So frozen, true. Cool. And that's literally it. We tell UMI to send and confirm the transaction. And now what this will give us is a signature that we can use, for example, to see on the Explorer that our collection has been created. Cool. So this is literally it. Nothing else is needed for our collection. Now we do the same with the asset. So same as we did before, we generate a new key pair that we're going to use for the asset. And then we just straight go into the create asset transaction that follows the same thing that we did for collection. So await. This time we're going to use the create function, UMI, and we pass in the args. The args of the create function are the same of the create collection, pretty much. So it's going to be asset. Then, if we want to add it into a collection, we will need to pass in the collection as well. But this is a optional data because we might not need to pass in the collection. For example, we don't want to add the collection to the asset to the collection. So it will probably require us to, let's see, do that as a public key, I guess. Yes. So we just say collection dot public key, because what we did before, actually, I think, yes, actually we need to pass in a signer, sorry. Other than that, the create function will ask us for something that it's not into the create collection. For example, we have both the update authority and the authority. So the update authority field is used, for example, if we don't have a collection and we want to give like the update authority over the asset to somebody else. So we will need to pass in the update authority. If we pass in the collection, we don't need to pass in any update authority, because as we saw before, in the update authority field, if we have a collection, we'll go the flag collection and the pub key of the collection. But in the case of putting a collection, we will need to add the authority fields. And this authority field is the update authority of the collection. In this occasion, everything is pretty much like, as we said before, authority, payer, update authority, in this case, even owner, are all optional fields because they are auto-populated by Yumi based on the signer identity and the signer payer. So easily, we could just, as a collection that we will need to put in name, call that asset number 1, for example, the URI. And this could be generating our asset. In this occasion, we want to add the attribute plugin. So we're going to add plugins, as we did before, vector, type, attributes. And then here, it will need the attribute list field, that inside is a vector of key. In this case, we can say workshop date. And value, that will be, today is the 4th, so. Perfect. And now we have our asset that has as attribute the date of the workshop. Cool. Then as we did before, send and confirm, Yumi, and we can get our own deserialized signature directly into this console log that will give us the Solana FM link to access the transaction. So yeah, I guess if we create a new terminal, and we say int asset, oh yeah, my bad, made a mistake. This is still connected, yeah. We have the collection address.
That's the minting address?
Yes, this is the mint address of our collection. Now we created our collection. And we got the asset address. And now the asset will be created as well. So if we see here, for example, on Solana FM, we will see that we just call the create collection instruction, and that at the link that we created before, there is a collection NFT. In this occasion, the image naturally doesn't show because I didn't upload a URI. But yeah, and we just created the asset that is inside of that collection as well. Cool. So one thing about frozen asset is that you can't actually transfer them and you can't actually burn them. So in this occasion, since I want to showcase how to burn the asset as well, we will need to unfreeze it first, and that's why we're gonna use the. Oops. Okay. That's why we're gonna use the update plugin instruction before, and then the burn asset function after. So to do so, we can. First of all, we get the address of the asset. We can pass that in as public key, and then we can take it from what we created before. So here, oh, I erased it. Oh, no. Oh, yes. 1 second. This will be our collection address. And this will be our asset address. Cool. Then we will need to fetch the asset. We do that by using fetch asset. We pass in UMI and the public key. Then we're going to console log the asset to show the fact that when we fetch the asset, all the data about the plugin, for example, that are on the collection, and the asset will show. So we don't need to fetch the collection, both the collection and the asset, to see all the plugins that are actually associated with the asset itself. Then we do the same to fetch the collection. And this is done because we actually need to pass in the fetch collection and the fetch asset inside of the update transaction. So now we can use the update function, the update instruction, update collection plugin instruction. We pass in UMI and the fields that are needed. You can see that the fields needed are just the, first of all, the collection. Then everything is optional as always. And then we will need to pass in what's the plugin that we want to update. So in this occasion, we just pass in collection. Oh, we need to add some awaits here and await here. Yes. I'll probably this will just in public. Okay, and then we're going to pass in the plugin. It's going to be of type permanent freeze. And then frozen false. So you see here that we can only update one plugin at a time. And that's why the fields called plugin and non-plugins, and there is not actually a vector, but there is only one plugin that we can update. So then we do send and confirm, pass in UMI, and we just updated our collection. Cool. Now that we finally unfroze the asset, we can actually burn it.
Question?
Yes.
Since we don't have it up yet, so we can't follow along and change the
Yes.
file while you're doing it. At the end, can you save this one, like with everything done to a branch, so we can have the empty one and the finished one, and we can look at the diff, so we can see the change.
There is actually there is two different folders. One is the examples folder. The other is the template folder. Template folder is what I just populating right now. But if you go into the example folder, there is pretty much everything that I already did.
Everything already done. Okay,
Yeah.
so we'll have those.
Yes.
Perfect. Thank you so much.
No problem. Cool. So we can see what are the requests for the burn. It's just to pass in the collection, the asset, and then as always, payer, authority that are completely optional. And there is no args because we are just burning the asset, so there is no need for any input. And just like that, it's done. 2 lines of code. Cool. So let me need to update here to DevNet because I forgot to do that before. And just need to pass in the different address, and then we can test it out. Cool. So if you do burn asset, Just gonna get a response soon, hopefully. Oh yeah, I forgot to add here. Yeah. Oh yeah, we can see here that we just burned the asset. So if we see on the Explorer, we're just gonna see burn V1, and the rent got back to the burner. So yeah, that's it. Super, super easy. We'll just use four different instructions: creating a collection, creating a mint, and then updating the collection and burning the asset. And this, as you saw, was like super, super easy, thanks for both the SDK that Metaplex offer natively and the way that Yumi works. So yeah, hopefully it was interesting. Hopefully you guys learned how to do that yourself. The GitHub repo will be uploaded shortly, and you can just recreate the templates yourself without any problem. So yeah, thanks for hearing me out.
I'm not sure actually. The question is, we do break now and then they do
Yes.
coding and then 1 hour. How much time do we give? Like 1 hour till 1?
Yes, let's do 1 hour. Yeah.
Okay, 1 hour code, free flow coding, and then about the bounties, we also so it's basically bit.ly day 3 minus bounties, and then it will bring you to this website here. And you can see here the bounty for the thread and the bounty for the programming challenge. So let's say you want to go to the programming challenge. All you have to do is you click on the link, and then it will bring you to the website on Super Team Earn. And then you can see the description and the submission requirements. It's not on stream? Okay. Let's see. Okay, let's do just one more time. Very quick. This is my screen here. So as I said before, we have this website here. The link to the website, I made a bit.ly link. The bit.ly link is bit.ly/day3 minus bounties. And then you'll see here the 2 bounties, one of the thread, one of the programming challenge. And as I said before, you click here on the bounty challenge. And then you can see description and the submission requirements. You also see the deadline, how long it is. And then to submit, all you have to do is basically, once you're done with your work, you say submit now, and then it's going to ask you for what you need, right? Link to your submission will be your GitHub link in this case. Okay, and the tweet link, because this is the link for the challenge, you don't have to put it, but of course, if you do it for the thread, you need a tweet link. Okay, that's been it from our side. We continue with the You and Me, Yumi 101 with Leo. And yeah, have fun. Yeah. Guys, can you please slow down a bit the voice, because we continue with the program, so everyone who wants to hear something can follow. Thank you.
Good. Oh, wait. One second. Yeah, 1 second. Yeah, I'm trying to join now. Does it work? Yes. What? Oh, okay, great. Okay, guys. So second workshop of the day. We saw before when we went into the code a little bit, we saw that we started using Yumi. So now it makes sense to just do 30 minutes. We're going to talk about how Yumi works, what you can actually achieve with Yumi, and then we're going to try we're going to code a little bit with just using Yumi and the client side of Metaplex. So what is Yumi? Yumi is a modular framework that provides the zero dependency library to interact with Solana client. So what does this mean? Is pretty much Yumi, first of all, is you could think about Yumi as the Solana Web3.js created by Metaplex. So everything that is possible to do with Solana Web3.js is possible to do with Yumi as well. Additional to that, we have clients that are directly integrated. So for example, we're going to see today MPL Toolbox. MPL Toolbox has a lot of helpers to use tokens, to use the system program. That makes it very, very easy, and even easier than Web3.js to use. Or in that, you can create your Yumi-compatible client using Kinobi, for example, and then directly plug and play from your smart contract to the client interface using Yumi. So the three main functionalities that Yumi has, first of all, it's completely compatible with Web3.js. So it's not a replacement, but you can use both. This is done because there is actually adapter available for most of the things. So for example, transaction, instruction, key pair, and public key. They don't directly communicate with each other, but helpers and adapter are available for you to convert from a Yumi compatible transaction to a Web3.js compatible transaction. Then, as I said, we have the Toolbox helper. Toolbox is a package that is natively compatible with Yumi, and what it does is that it's designed to complement Yumi by providing a set of helpers for Solana native programs like the token program and the system programs. Last and for all, we have Kinobi. Kinobi introduces a language-agnostic representation of Solana clients, which can be composed of one of several programs. So what does this mean is you can create Yumi-compatible clients using Kinobi by simply passing in your program and all the fun. It's the way that we actually create our own, like we saw before the MPL Core SDK. The MPL Core SDK is built up with Yumi. It's built up with Kinobi. So you guys now, after 3 days, should be a little bit more familiar with how Solana works in general. So first of all, you guys know that there are clusters. So testnet, devnet, mainnet, and localnet. And the same as Web3.js, the first thing to do when connecting with Yumi is actually passing in a cluster. So instead of using connection, that is the Web3.js, the Yumi version of Web3.js connection is create Yumi. We're going to just pass in the cluster that we want to connect to and the commitment if we want. It's an optional parameters. After that, we can generate a wallet. We saw before how this pretty much worked when we created like the asset public key and the collection public key. But by just doing generate signer, we will create a key pair that is compatible with like all the wallets that we're going to use. After that, we already introduced a little bit about how signer works in Yumi, but pretty much there are two different identities. The first one is the signer identity, that is the user of the application. So pretty much, and the second one is the signer payer, that is the payer for transaction and storage fee. So to think about why we actually wanted to decouple these two different identities is because imagine this. You want to create, you want your user to claim an NFT, but you want to subsidize the cost. There is no easy way to actually do that natively. With Yumi, actually, this is super easy because you could use as signer identity the keeper that you grabbed from the wallet adapter, and the payer identity could be a keeper that is stored in the backend of your application. And this makes it super, super easy because now you don't need to specify the payer, you don't need to specify who's receiving the NFT, you don't need to specify anything because Yumi already know that stuff. Naturally, we know that it's not something that everybody uses every day. So when we set up the signer identity, we're going to set the signer payer as well. To not do that, we can see here that, for example, we could say use signer identity, my keeper, and then false. And this will just say, put in the Yumi identity and not the Yumi payer. Or we can just, for example, set it up another way and then just setting up the signer payer by just doing Yumi use signer payer my keeper. The SPL system program. So if you guys might be familiar, there are a lot of native programs in Solana. Native program means that these were developed as the core infrastructure for the old blockchain. And in that, we have the two main programs that everybody uses every day is the system program and the token program. The system program, what it does is it operates to create new accounts, transfer lamports, and pay transaction fees. Pretty much everything that is lamports related is handled by the system program. So there are actually some helpers that we can use with the MPL toolbox that actually makes it super, super easy to, for example, create a new account. When you create a new account with Web3.js or like the normal instruction, you will always need to, for example, specify what's the rent, specify the cost of the rent, specify the space, specify the accounts. And this can be done with the Yumi as well by using the create account function. But there is an easier way to do that. That is create an account with rent. So you don't need to pass in all the value that a normal create account needs, but you can just tell Yumi what's the space and what account needs to be added to, and the rest, Yumi will figure out the rest. Another cool thing is airdrop you can airdrop some DevNet Sol directly into your wallet by using the yumi.rpc airdrop function. And if we want to go a little bit more further, so the main problem with Faucet on Solana is that you can't ask a lot of airdrop during the day because you will get you will get rate limited. So the way we can not do that is actually creating an airdrop if needed function that we're going to see later. And the way that this actually works is it's going to call the airdrop only if the balance of the Yumi identity public key is less than 2 SOL. So the way that this works is the first time you do an airdrop, maybe you do an airdrop of 4 SOL, and then you just call the airdrop function when you actually need it because you're low on balance. And this will help a lot with not getting rate limited or like commenting out the airdrop function, or like airdropping to a different faucet. You just put like an airdrop if needed, and it works like a charm. Last and for all, for helpers that can be used with the MPL Toolbox program, we have the transfer sol. So you can perform a normal Lamport transfer using Yumi Toolbox, but the very cool thing is you could use the transfer old sol function. What this actually do is for example, I'm testing with a random wallet. I just ended all my tests. I don't want the wallet anymore. Instead of wasting all the sol that are there, I can just use transfer old sol, and all the sol from that wallet will be transferred in the wallet where that I actually use maybe every day. And this is actually very, very helpful for testing, but in general, it makes it very, very easy because you don't have to put an amount there. It's all abstracted away by Yumi itself. As we said before, Toolbox can be used with the token program as well. That is pretty much everything that manages token, so token account, mint, transfer, pretty much everything that requires token is managed by the token program. And there are some easy way to, for example, create a token account. There is a big difference between token account and associated token program. Yesterday, Andre taught us how associated token program works. That is not other than just a PDA that is derived from the mint and the owner. But this is not the only way that you can receive token, because you can create a token account that has like a random address. It's not usually used because then it could happen that you have multiple token account, and so that's not it's not very optimal, we can say. But both of them can be done with Yumi by using the create token or the create associated token instruction. Same, we could use the create mint instruction to create a mint account, same as Web3.js. But one very cool thing that the Yumi abstract away for us is that by using the create mint with associated token, pretty much we do all the instructions that are needed to set up a token in one single instruction. So we create the mint account, we create the associated token program that is where we're gonna get the token in, and then it's going to mint the token all in a single instruction without having to supply 3 different instructions. So it makes it very, very easy. After, when we're going to see the difference between them, it's like 1/5 of the code needed just for using the helper function instead of like setting it up normally. So yeah, I wanted to do a brief introduction on that, but I think the most important part now is going to be the code. So. Okay. Let's see. This is the template. Okay. See? Perfect. Okay. Good. So, first and for all, oh yes, you're right. Sorry. It's good? I can do one more. Yeah, I'll do. Yeah, it's fine. Cool. So, as we said before, what we're going to start to do is we're going to create a Yumi and connect it to DevNet. This will make sure that all the transactions are actually routed through DevNet because we actually selected that as a cluster. One cool thing about Yumi is that, for example, I could set up multiple clusters and just use. I usually do, for example, when I'm I don't know, you need to fetch some data from mainnet, and then you want to generate on DevNet. So what you can actually do is something like cost DevNet Yumi, and then it's like DevNet, and then you can do. And then you can change the Yumi to pass in based on what we want to do. This occasion, we're just going to use DevNet, but it's something that it's cool to know if you're actually working with multiple cluster. So what we're going to do later is going to just do the generate signer. So because we want to create a keeper for it. And we're just going to get the secret key as well. So now we have the secret key that we can pass in, for example, into like wallet.json file. And what this wallet.json file do, pretty much as we can just tell, since now we have loaded up the signer into the Yumi instance, we can just do Yumi.identity.public key, and this will fetch what the public key from the Yumi that we just set up as, it will fetch it from there. So then we, for example, we can do, let's airdrop for Sol. And as I said before, we should actually make it that it's an init if needed. Sorry, an airdrop if needed. So what we can do is Yumi.rpc.getBalance. That is the RPC function to see how many Sol. Test. 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 Cool. So as I was saying, we're going to create now a function that pretty much just airdrop and perform the Yumi.rpc.airdrop function only when we are low on Sol. So in this occasion, the Yumi.rpc get balance is the RPC call that pretty much tells us how many Sol are into the public key that we're going to publish right now. So in this occasion, we're going to do Yumi.identity.public key. After that, we can just say it needs to be less than 2 Sol. So yeah, the way that this works is like it will fetch the balance. If the balance is less than 2 Sol, it will try to airdrop 4 Sol into the wallet.
Is there a minimum of Sol that can be checked?
No, I can check like even 0. It's just 2 usually is a good balance between not being too low on Sol and not like having to refresh every time. Perfect. So now we can actually check that, for example, how many Sol we are by using the same thing. So balance of Yumi.identity.public key after airdrop, it will be Yumi.rpc.getBalance. We can actually not do the basis point. It's not needed. Cool. So now what I want to show you guys is we need to generate a new wallet, generate a new public key, and transfer some Sol from point A to point B. So we generate a new signer. Then we create a transfer transaction. Transfer transaction is very easy. It's what we did already with Core. So it's transfer Sol. Now we always need to pass in the Yumi that we want to use, and then all the arguments. This time around, we just need to pass in the destination and the amount. This is because the from wallet will just pick up the Yumi identity dot payer as the from wallet that will send the Sol from. We could specify whether I think it's source. Yeah, it's called source, but it's not needed thanks to Yumi. Then we do send and confirm. And now we can have our signature and already do transfer complete. Cool. So now what we want to do is we're going to talk about, so you might know that in Solana transaction can actually be multiple instruction. So Yumi support that behavior as well using the transaction builder. So what we're going to do is creating a transaction builder instance and then add every single instruction. So what I want to achieve here is that from wallet to send another 0.5 Sol to the to wallet, and then the to wallet to send it back all together. So we do add transfer sol. It's going to be, the destination is going to be the to wallet. Then let's add a new function, and it's the transfer all sol that we saw before. Pretty much we are emptying the to wallet into the Yumi identity public key. We can do this time.
Put money in, Solana in, and then we take it out.
Yes. It's just to show, it's not something that we would normally do, but it's just to showcase the transaction builder and the transfer all sol function. So this time around, instead of doing the send and confirm, we need another signature, because this time around we're transferring all sol from the to wallet, and the to wallet is not inside of the Yumi instance that we just created. So what we want to do is, first of all, we do build and sign. What build and sign does is it creates the transaction and it's signed with the key pair that is inside of our Yumi. After that, we need to do transaction equal await to wallet sign transaction, and we're passing the transaction again. So now in the transaction, we just don't have the transaction builder that is built and signed. We have the signature of the to wallet as well. Oh yeah, this should have been here. My bad. Cool. And now we just send the transaction, and we can deserialize the signature as we did before. So yeah. So in the terminal, oops. Oops. Okay. So now we wait, and we'll probably get a response.
That's right now on mainnet running, right?
No, on DevNet. Yes. Yeah, we can't ask, unfortunately, we can't ask an airdrop on mainnet. Would be pretty good, but unfortunately, we can't. Cool. Transfer completed. That's one completed. So if we see the transaction, interesting. Oh, because, yeah. We can see that what happened is the two transactions sent 0.5 sol to the from wallet, and then the from wallet sent back 1.5 sol because we sent 1 sol before. And so transfer and transfer. Cool. So now we talked about the system program. Now I want to talk about the token program. 1 second, let me clean it up. So it's less of a mess. Okay, cool. So now we have the token. So what we can do right now is, first of all, we create a Yumi as we did before. Then this time around, instead of creating a new wallet and airdropping to that, we can just read from the wallet that we just created. So we parse, we read the file, and we parse all the information that is in there. And what we do is the same thing as we did before. So create a signer from key pair, and then we create a key pair from the secret key that we just got by reading the wallet.json file. After that, we use the signer that we just created as a signer identity, and this time around, we added a new package that has MPL token metadata, and this is needed because we're actually interacting with the token program. I already added the airdrop if necessary. It's nothing more than just the function that we just did. So we start with creating an airdrop if necessary. So, and now what we need to do is create a mint, create a token account, and mint some token inside of that token account. The way that we do this is generate signer, Yumi. And now we need to call 3 different instructions. The first instruction, we use the transaction builder as we did before. What we do right now is create mint. We can see that the thing needed are the decimal, the mint authority, and the freeze authority. In this occasion, the mint authority, when you create a mint, you always need to pass in the mint authority. In this occasion, it's optional because it will default to the signer, the signer identity. Yes. Yeah. This one. So we're going to get back to those questions after, since they are not for Yumi. But at the end of the lesson, I'll come back to those questions. So what we need is mint, decimals. I usually like to set it to 6. The mint authority we don't need to pass in because I want that to be the Yumi identity public key. I'm just going to say that the freeze authority needs to be null because I don't want anybody to freeze my assets. So after that, we can create an associated token account. Associated token, pass in Yumi. And then what it probably needs to is going to be the mint and the owner, I guess. Yeah, the payer, the ATA, the owner, and the mint. So we can just, for example, in this occasion, we can just pass in the mint because the rest will be defaulted by the way that Yumi works. Like the owner is going to be set to the Yumi identity, and the ATA will be created by that, and the payer will be set by the payer identity. Last and for all, we need to mint some token. So mint tokens too. Pass in the Yumi, as always, and let's see what's needed. We need the mint and the token, and the mint authority. The mint authority doesn't need to be passed in because it's always the Yumi identity already. So we can just pass in the mint, mint.public key, and then the token. So this time around, we need to find the associated token program before actually passing it. So we can do that by using the find associated token PDA instruction that by passing in the mint and the owner will automatically create this for us. Cool. And now we just need the amount. We want to mint 100 token, so we can just do E6. So what I did here is, since we have decimal, if we actually want to mint 100 token, we want to mint 100 multiplied by 10 elevated at the 6. So instead of doing all this calculation, I can just do E6, and it will work.
Because of Yumi?
No. This is a TypeScript. It's normal TypeScript code. Cool. So yeah, just created my first mint and just minted 100 token into 3 instructions. But if you remember what I said before, there is an easier way to do that. So first of all, actually, I want to actually check that we actually minted those tokens. So what I'm going to do here is there is a function that is called fetch token. And pretty much by supplying the address of the token account, it will be possible to see all the information about that token account, for example, the amount as well. So find associated token PDA. We do exactly what we did before. And public key, owner, and then everything else dot amount. So what we're going to do right now is going to fetch the token that is derived by the find associated token PDA instruction, and then get the amount for that and tell us what's the amount. So we can see that we actually minted the 100 token. Now, as I said before, there is actually an easier way to do that. And we will need just one instruction to do exactly what we did in this tree instruction. That is, create mint with associated token. Super easy. We just need to pass in the mint. There needs to be a signer. We just need to pass in, not even the owner. We just need to pass in the decimals, the mint authority. Oh, no, not the mint authority, the freeze authority, because the mint authority will be defaulted to us, and the amount. This is everything we just need to mint 100 token into our own public key. So we do the same that we always do. We declare the signature, and it's done. So before running the script, the last thing that I want to do is do the same thing that we did for the system program. So create another token account and sending some token inside of that. So we create the destination, and we can just say, we can generate a new signer. We can get the public key for that, because we actually don't need the to sign with that destination. And what we want to do now is just transfer 50 token from the wallet to the destination. You see that there are actually two different instructions that we need to, and this is because you can't actually send token to a wallet, but you need to send the token to the associated token associated with that wallet. So before we need to create actually the associated token account. So we do the same as we did before. We use the create associated token. This time around, as field, pass in the mint. And, oh, wait, 1 second. Yeah, 1 second. I made a mistake. We can't actually recreate with the same address for the mint because it's already initialized. So we can't initialize another mint inside of the mint that we just initialized. So we create an associated token program. This time we do with the mint. And we need to pass in the owner this time around, because it's not going to be the keeper that we have in our Yumi instance. What we will need to pass in the destination. Cool. And now, last thing we need to do is the transfer token instruction. Yumi, we pass in the source will be our, actually we need to still pass in the source because this time around will be the associated token program, token PDA. So the Yumi identity, the destination needs to be the associated token PDA that we just created, and as amount, we're just gonna pass in is 6. Cool, we send and confirm.
I have a question.
Yes.
You have two minting associated token accounts, right?
No, I'm
Only one, or
yes.
I'm a bit lost here.
I created one associated token,
Yeah.
and now I'm just finding that associated token because I need to send it to that.
All right. But then you have two mints. You have the first mint.
Yeah, the first, like this is just the second mint has just been created to showcase the fact that it's easier to do that. Okay. But it's two totally different mint. We're just gonna send the mint one. Yeah, sorry, I just went over it pretty fast there. Cool, and then we can check the balance of destination the same thing, the same way we checked after the first mint. Cool. So if now we do. guess we got rate limited on the airdrop. Oh, yeah, because this is not the one that I need to change. So this is the first mint address. Then we saw that they created mint, and then we have under token. You can see here we did 3 different instructions. One, that is the create account. This is for the create mint instruction. Then there is the initialize mint, and then there is the create token account, and then there is the mint2 account, the mint2 instruction. Then if we see the optimized version of it, it's just, actually I think I made a mistake in the getting a signature for that one. I guess it's, yeah, this is.
Can you also share the whole screen because
Yes. Good, perfect. And then the last one is going to be the transfer to the destination wallet. And we can see that is just a simple create the associated token program and then the transfer instruction. And we can see in the terminal that the balance is actually 50 token because then it's like 60. So yeah, that was everything that I had for the Yumi 101. Hopefully it was interesting. And I guess I'll go to the 2 questions that I had from all. So
This one first.
yeah, so can app data be used in program to issue tickets like a raffle system? Yes, app data can be used for app data is just, it can be used for whatever needs to be your use case. It's just, it can be used to issue tickets because that will just be you can just, for example, you will need to delegate the mint authority to the new wallet. And you can't actually use app data for minting to issue other tickets, just to change a part of the asset data itself. What's the difference between Yumi Core, between Core and Candy Machine? Candy Machine is just a tool that you can use to mint tokens or using Core or using token metadata. But we're going to see later after the lunch break how to use Candy Machine, and we're going to explain a little bit more about that.
One more question.
Yep. I can imagine those optional parameters can be comfy in some use cases, but will cause problem for sure, like missing or forgotten override parameter causing signer confusion. Do you have a function set without all the optional? No, we can't. We don't actually have that, but no, we don't actually enforce all the signer because it's simpler to just have the optional parameters. Naturally, you can just you can always reference the function itself to actually see all the parameters that should be there.
Yeah, that was it.
Perfect. Thank you for tuning in.
Will we continue at 3 or?
Yes. Guys, you're missing for the food. You still need to order. Oops.
No, we have. but it would maybe be good for the people that they know. Are you in the Telegram group? Perfect. I will just send you.
We're starting. Björn, should we start?
Yeah, we're good. Can you hear? Three work? Yeah, that you can. We start we can. Good.
Perfect. Okay, guys. Last workshop of the day. Then we're gonna do some office hour later if you guys are interested in learning more about core and like Metaplex in general, like what's your use case. So we're gonna start by talking what is Metaplex Candy Machine. So Candy Machine is the leading minting and distribution program for fair NFT collection launches on Solana. What does this mean? So we showed before how to mint a core NFT, to mint a collection, and you saw that as much as it's easy, there is a certain more easy way for people. There should a better way for people to mint entire collection of 10,000 NFTs. And that's exactly where Candy Machine comes into. So how does it work? The user, when setting up a Candy Machine, can decide, first of all, how much token or SOL they want to sell their NFT for. They're gonna then charge up all the data. So, for example, what's the URI, what's the name of the collection, and like how the different thing pairs together. And after doing that, pretty much the user could just access the Candy Machine, pay as much token as the creator wants, and get back a random NFT after. And it's called a Candy Machine because if you think about it, it's like how a Candy Machine works in the real world. You put a coin inside of it, you twist the thing, and a ball with your NFT comes out. So, okay, is there anything special about Candy Machine? It's just like a normal minting program that makes it easier. No. There are a lot of different guards that makes Candy Machine very, very useful for everybody that wants to mint their own collection. For example, first of all, we can directly set a start and an end date directly inside of the Candy Machine. So we don't need to add any other validation because we just need to decide when we want to start the mint. And the Candy Guard will make sure that the current time is allowed to mint. There is an allow list program. So pretty much you can create a list, a wallet address to determine who is allowed to mint and who is not allowed to mint. So for example, you want to create like a private pre-sale or like a private mint, a whitelisted mint. You will just add all the address that you need to the Candy Machine, and this will make sure that only the people on the allow list can mint. Then we have the bot tax. If you want to make sure that your minted doesn't get botted, you can add this bot tax Candy Guard, and pretty much what it does is if somebody starts spamming your Candy Machine and like the transactions are failing, it will start charging the bot fees for like botting. So pretty much it's like if somebody tries to bot the mint, every time they send a new transaction, they will be charged more for the cost of the mint, and it will fail the transaction. Yes.
Where is the tax going up?
It's going to the creator. Yeah, the creator is taking ownership, but it's just like a measure to prevent people to just spam, because if they know that there is a fee, if they incur in a fee by spamming, they will just not spam. So in theory, like hopefully nobody gets taxed.
It's really nice.
But yeah.
Yeah, it's really, really nice.
And then there is the token payment, because the thing is, the candy machine at the start doesn't, it's not like it doesn't support natively any currency, but pretty much like the candy machine start with free. And what you need to do is add some candy guard, for example, to say, oh yeah, I want people to pay in tokens, want people to pay in Sol. And so there is like a token payment guard and there is a Sol payment guard. We're gonna see today the Sol payment guard. We're not gonna use token payment. Second of all, there is the mint limit. So what that enforces, like for example, I want only people to mint one time for wallet. Perfect. So before minting, the guard will look into the wallet and see, oh, is this guy did this guy already minted its NFTs? Yes. No. If it yes, they failed the transaction. But it's not just that, because candy guard are pretty powerful alone, but when you combine that with the guard groups, it becomes a fully fledged product into a simple SDK. So for example, I could create different rule for different time, different rule for different mint, or I can even, like for example, I can set up my candy machine to mint in 3 different tokens by just setting up different groups. So for example, in this occasion, I set up different combination of candy guard that resemble what was pretty much the frenzy of NFTs when everybody was launching. This pretty much was the setup that everybody used. So for example, there is, before, we can say like a whitelisted mint. So there is a Sol payment on 1 Sol. There is a start date that is for 4 p.m. to 5 p.m., for example. Then there is for example, there is a gate. In this occasion, I made an NFT gate, but it could be an allow list gate, for example, and a bot tax. Usually, it's always good to just add the bot tax everywhere because you don't want your collection to get botted. But so this means that from 4 to 5, everybody that minted and it's on an allow list will pay 1 Sol for the mint. Then it becomes, for example, the public mint. And so now there is a Sol payment guard that is 1.5 Sol, and the start date is 5 p.m. So if anybody that is not on an allow list will try to mint during the whitelist phase, it will not work because the late guard group start at 5, and this doesn't have any restriction. And for example, if people that are in the allow list try to mint after 5, they will still pay 1.5 Sol because now the early guard group is closed because it's from 4 to 5. And pretty much you can add as many guards as you want. Other thing that makes it very, very easy to use is, for example, there is this config line setting. What does a config line setting do? So naturally, for example, all the data, for example, the name, the URI, and everything, if the URI is different for every mint and the name is different for every mint, naturally you will need to store all of that into the candy machine account because you need to have a way to fetch that data. And we're going to see later why. But by using this config line setting, pretty much we can group together all the information that replicate during the asset. So for example, if we have like a prefix name and a prefix URI, so we have like rweave, or like we have rweave, and then it's like, usually it's a manifest ID, and then you can use, for example, 0.json, 1.json, 2.json, 3.json. We can pretty much, instead of like saving every time, for example, 64 character, there is rweave plus the manifest ID, you can just tell the candy machine to use the config line setting, and what it will store is just 0.json, 1.json, 2.json, 3.json, and when you actually mint the asset, it will automatically recreate the correct URI by putting together the config line setting and the specific title of the URI. And other than that, there is like the is sequential Boolean, and this makes it easy to not minting. For example, the first mint is not going to be the asset 1, but it could be the asset 10, it could be the asset 20, it could be the asset 25, and then it's like the second mint is not going to be the asset 2, but it's like completely in randomized order. And this so it helps very, very much to make the core candy machine run significantly cheaper. You'll see that, not in our example because it's very, very lightweight the way that I set it up, but For very, very specific mint and for very, very advanced mint, you could even pay 8 sol for like rent, 8 sol of rent. So rent is reclaimable, and we're going to see later how. But pretty much just to start a candy machine, you would need to pay 8 sol that then it get refunded after you actually use that. So yeah.
Is there a reason why there are different rates for the rent?
It's this like rent is how much space you occupy on chain. So for example, here you save a lot of space, and so the candy machine becomes way cheaper because all the character, like each character is 1 byte. Every byte costs some sol in rent. So as many bytes, like for example, in a 10,000 collection, if you can save 64 bytes for every mint, it becomes a lot of money. And other than that, we have some hidden setting. So the way that this works is pretty much every asset minted with the hidden setting on will default to all with the same name, all with the same URI. So it's like a TMP that we can say that it's like a random image or like an image that you decide to be. So everybody can mint the same asset, and then you can update it to the right asset that should have been there. But so this makes it even fair because, for example, during a mint, if everybody mints all the rares and like all the commons are the only one remaining into the candy machine, probably people will say, maybe I actually don't want to mint that. I don't want to mint anymore because I don't have the possibility of minting a rare. I don't have the possibility of minting a legendary. So what projects usually do, they mint with an unrevealed NFT, and then they reveal it. How do we make sure that the revealed NFT is actually what it should be? There is an hash that pretty much you get the full list, you pair all the assets with like the right URI, and then you hash it. So you pretty much you run a cryptographic function to make it not readable. But at the same time, what you can get then is after the update, you get the current asset list. You can rehash it and verify that both hash are the same. If both hash are the same, this means that the updated asset are the one that should have been in the first place. Any question?
Does it happen automatically?
No, it's like the hash is on chain. Everybody can look at it. And so, for example, if you want to make sure that the assets are, you will need to fetch all the assets, hash it, and see if they are actually correct.
Okay. Then there are no instructions that I need to create once I want to reveal the NFT.
Yes. Once you want to reveal the NFT, you will just need to do like an update. The same thing that we did before with the collection. So the update plugin, there is the update function that is to change the URI of the asset, the URI and the name of the asset. And so you probably would have the same list that you hashed in like a database, and you just run an instance of update for every asset in your collection. Cool. So let's do a recap of how the candy machine works. The authority can create both candy machine and candy guards and candy groups. The user then can interact with the candy machine and mint an NFT. And at the same time, all the money that are spent when the user interacts with the candy machine gets sent to the authority that can withdraw the money and profit of the candy machine itself. So yeah, I guess let's see how that looks into code. Somebody has any question about how the candy machine works? Cool. Yeah, sorry.
Like you as the website hoster, you take a lot of meme collections, put them into the database, and then connect to the candy machine, and you bring it onto the website and see that as much users as possible interact with it, and if they throw in some Solana, they get out the meme.
No, the candy machine is like the purpose of the candy machine is make it easy to mint. Then everybody will need to create their own front end. And there is actually a guide on our website that it's called, it's like under the core candy machine, and the guide is called how to create the front end and connect the candy machine. So you have all the instruction, what we're going to go through today is like all the instruction that you need to create your candy machine, and then to set it up into a website for people to mint, there is another guide that you can follow.
But where's the aspect that the user puts in money and doesn't know what comes out?
It's the native functionality of the candy machine. It's like you pay money. Like the creator says, yeah, to mint this NFT costs us two Sol. You pay money and you get back an NFT.
So it's not anymore. So it seems in a way you don't look on the website. This is NFT.
Oh no, it's not. No, it's random. Yeah, it's like you can't choose the NFT. You will get an NFT randomly.
So first of all, it was like you can choose. Now it's like you can choose.
I think it will never. You couldn't never choose what NFT. Like in a marketplace, you can choose what NFT to buy, but like when you mint, you can't choose what like NFT to mint. It's like in a marketplace.
No, I as a creator can't choose which NFTs I got when I minted.
No, wait, I didn't understand.
No, is it like when I am a creator? So when I'm creating, I'm minting an NFT collection of 200 NFTs. Where is it important to use the candy machine now?
For the mint, for everything. You generate the whole collection, like you generate the whole metadata collection. You upload the metadata, and then you do everything else with the candy machine.
But where's the aspect of? Didn't you explain like there's an aspect of you don't know what's coming out?
Yeah, it's like the NFT is randomized. It's like there is a pool of 300 NFTs that you created a collection with 300 different assets, but like you can't choose, for example, I want this asset of this collection. One of the assets inside of the collection will come out from the candy machine.
But why would you use this to randomize your assets?
It's like you have to, because I will just get, like, if I can choose what asset to get, I will just get the rarest one, and nobody will mint the collection further. Yes.
So for what text are smart that how does like prevented? Like KP thing is like one of the first largest NFTs, right?
Yeah.
So that's what you said, nothing new. It's just you presenting it right. It's not a new feature.
No, it's not, no. The candy garden. No, I'm just like talking about how to mint the candy.
I think it's got the bots are smarter. Let's put it this way.
Yeah.
So you've got it improved, or like how can?
Yeah, it's improved, but you can reach till a certain point. Like,
So is it bot free now, for example, like on the risk is put in a good.
I don't want to say it's bot free. I want, like, it prevents botting. I can't say it's bot, like, I don't think we can say it's bot free.
And because of like what we do with copy trading did a lot of new meta in this whole region game. If I'm copy trading as on the bot, I would say, like if I copy trade you and a friend of you, am I not a bot for your system?
No, it's like the botting is if you try to mint multiple times. Like if you try to mint like 100 assets in like 5 seconds, you're considered a bot. But if it's like that, because it's for the chain, it's impossible to say what's a bot to what's a person. It's just about the frequency and like making it fair for everybody.
For the tracking machine to be used by someone outside of Metaplex, do we have to pay some rent?
No, it's yeah, it's a tool. Yeah, everybody can use it. It's completely free. Naturally we have a fee on the asset itself, but like if you mint it with Candy Machine or not Candy Machine, there is a fee both way for every asset minted.
The fee is not on the creator but on the user.
Yes.
And also, bot tries to buy, let's say, 100 assets in 5 seconds. What's the problem? It's failing.
If you don't care, it's like it's your choice. It's like if you don't care about bot getting 5,000 assets, you just don't activate the bot tax.
Okay.
Is this how Drip
No, I don't think so because no, Drip is not using a candy machine because we don't have a candy machine for compressed NFTs.
Any more questions?
Okay, is this big enough? Yes. Cool. So we come back to everything that we already did. Nothing much. So create Yumi. We get the wallet. We use the wallet as signer. We tell Yumi to use that as a signer. After that, we added the MPL Core program and the MPL Candy Machine program. Just to let you know, I'm going to use the MPL Core Candy Machine. There is the token metadata Candy Machine as well. But for this example, both of them function pretty much the same and have pretty much the same guards. But yeah, you can go on our website and see what guards are from the token metadata and what guards are from the core Candy Machine. So we start by creating a collection, a core collection for our assets. So same thing we did this morning. All right. Oops. Send it. Good. Then we deserialize the signature so we can look at it later. And now we can generate the Candy Machine. So first of all, we generate the Candy Machine keeper. Same as always, generate signer, Yumi. Then we create the Candy Machine with the collection. So we can use create, Yumi, and then let's look at what we need to put in. Oops, that's not this. It's this. Let's see. Yeah. Okay, so we can put in the collection. Then we need to put in the Candy Machine for sure. Then we can put the candy guards. The guards directly. They will need to be passed in as sum. Let me actually verify that I'm doing the same as the example, so you guys have it at home as well. Sorry about that. Don't remember what cards I put in here. So yeah, okay, the bot tax and the sole payment. So after that, there is the collection update authority that will need the Yumi identity. Then the items available. In this occasion, I will want to mint only 10. You can set up like 20,000, 30,000, 40,000, 50,000, whatever you guys think feels it's your use case. Then we can put, first of all, the config line setting. Oops, we look at it, it's going to be prefix name, name length, prefix URI, URI length, the same as we said before. So we do sum, open, prefix name, asset. I trust GitHub Copilot that it counted the, I don't think it's 50. 2, 4, 6, 7. Yeah, 7. Okay, yeah. Seems like, yeah. Cool. So as we said before, pretty much right now, if we created, for example, with Arweave, an asset, we will have HTTPS, Arweave, then slash, and instead of the metadata, we will have like the manifest ID. And then after the manifest ID, usually we the name of the file that we are uploading. So by doing the prefix URI, we can just like then upload just the name of the URI, and we'll save all that space. Like we'll save 29 and 7 bytes for every asset that we create. So we said bot tax. Lamp ports, last instruction, true. Solve payment, lamp ports, yes. So what we interesting. Sorry, what's missing? Cards. Oh, it's cards. Well, it's the same. Sorry about that. Let's see what's. Oh, because I think, okay, yeah. Oh, okay, I guess I forgot to add the thing at the end. Cool. So now we have created a candy machine that has, first of all, the collection that we just minted. We passed it in the collection update authority, how many items we want inside of it, what's the config line setting. We could have set it to none if we didn't want to save space. And what are the guards? In this occasion, I just put it the bot tax and the solve payment. So after that, we're gonna send and confirm the create. We just send and confirm the create instruction that we just created, and from that, I'm gonna just fetch the candy machine so we can see all the data inside of it. So now as I said before, now we actually need to add all the data about the singular asset for everything. And this is where the add config line instruction comes into place. So we do usual stuff. And here, we just need to put in the index and the config line. And the config line is like name and URI. So, sorry, 0. Yeah, so the index is going to say, so the thing is, you might need to add like 10,000 file to the candy machine, and they might not fit in a single instruction. So what the index does, it's telling the candy machine to start from that point. So for example, since we fetched the candy machine, we could have done something like these. Yes. Items loaded. And so this means that pretty much we're telling the add config line instruction to start from the last item added to the candy machine. In this occasion, since it's the first time that we're going to add anything, we can just put 0 because we know that the index, the starting index will be 0. But pretty much this is just needed when we can't fit all the adding all the asset in one single instruction. Cool. So now we have config line is name and URI. For example, now we can do just one because we already told with the config line setting, we already told that we want asset number, and so we can just say 1. Then we will need the URI, and same for this, we can just say 1.json, for example. And we can do the same for everything, pretty much. Yeah. 1, 2, 3. Cool. Let's see what we're missing.
Is there a function that I can make?
Yes, yes, you can. Yeah, you can probably just do like a for function and like run. Yeah, probably you could just, for example, do something like for. Let's put it here. And then you can do like something like config line push. One second. Yeah, something like this will work. And then you just do config line. Something like this will work. And then we need to pass in the candy machine. Cool. And we do send and confirm. Yumi. And we just created our first candy machine. Yeah, cool. Let me run the script. Collection created. And now we should create the candy machine as well. Yep, and we can see that all the data about it is here. Cool, config line added. So we're done. Cool, now we can just mint and withdraw the candy machine. So we can pretty much delete the candy machine and withdraw all the LAN ports that are used for rent. So let's get the candy machine address. Fetch, oh wait. Fetch candy machine, Yumi candy machine. We generated the asset because naturally we will at least generate a keeper that candy machine can use to add the data inside of the mint. And then we can just do the mint instruction. Yumi. Then we can see what are the arguments. There is the asset for sure. What is it? Yeah. There is the asset, the candy machine to pass in. There's the candy machine. Candy machine. Then we need to pass in the asset. and collection. That we can directly fetch from the candy machine data. Collection mint. And this, in theory, should be enough to mint the asset. But since this time we used a candy guard, some candy guard actually want some specific data inside of the mint v1 instruction. If you're not sure what the data needs to be, and if you actually need to add something there, on our website or into our developer app, pretty much for from every candy guard, there is written if it needs additional data or not. So in this occasion, I have to be honest, I don't remember what's the, and I need to add something from, the mint args for the sole payment. So what I would have done in this occasion would have been go to the developer app and just look at what arguments did I need to add for the sole payment guards. So send and confirm Yumi. We mint our asset, and then we can finally use the delete instruction by doing, I think it's called withdraw. Let's see. No, delete candy machine is the instruction. Passing Yumi. As argument, I think it's just the candy machine itself. Yes. Cool. So I actually need to add these two. Example here. Okay. Cool. So now, if I do mint and delete candy machine, we should see that we did everything right. We minted our first asset. So for example, this time around was the asset number 1. And if you saw, we just put one.json. No, we didn't put, sorry, and if we see, it's going to be, yes, I don't know if I'm going to show it. Yeah, I guess. T should be equivalent T. Yeah. I don't know why it's the Explorer it's not showing, but I think because in DevNet doesn't work. Cool, and then we deleted the candy machine and we draw everything. Instruction withdraw, so we can see that the change in sole balance, pretty much it gave us back the rent for it. So yeah, guess that was everything that we had for the candy machine today. So hopefully you guys are now familiar with minting your first candy machine. And yeah, if you guys need any additional guidance, just find me in the crowd. Cool. Oh,
1 second.
yeah. Yes.
First one.
Why do we need to delete the Kenny machine? You need to delete the Kenny machine only if you want the rent back. It's like you don't need to delete that, but there might be quite a lot of SOL locked into the rent account. So if you don't delete it, you will never get it back, pretty much. Where should we publish the metadata? IPFS. You can use whatever provider you want. I prefer usually to use Arweave, but you can use, for example, Iris and Bundler. You can pretty much use whatever metadata. If you go on our Yumi package support, for example, Arweave and Iris natively into Yumi, so you can upload the metadata from there directly.
That was it.
Perfect. Thank you, guys.
Okay, Leo, can you come for one more second, please? Okay, so guys, this guy just ran the whole day. I think he has deserved an extra round of applause. Thank you so much, Leo. That's been it for today from the lessons. We will be here still, so if you have questions, you can either ask in the chat or you can ask us if you're here. So please don't be shy. We also have the Telegram group to ask your questions. And then for those of you who are here, don't forget, there was, I think, Sharko said something about merch or something like this.
Yes.
Then we have pizza at 5 to 5:30-ish. And then there is the evening event at Prachtwerk in Neukölln. Lots of good artists, lots of free drinks, lots of fun. So I hope we can all see us there as well. And then, yeah, just enjoy yourself a little bit more. And then thank you so much also for attending, because this more or less ends the session here. Again, thanks so much to the Turbine guys. Thanks so much to the Metaplex guys. Thanks so much to every one of you for the questions, for attending. I had a blast. I hope it was also good for you and we all learned something. And yeah, thanks so much.